Hello, my name is Cordelia Dean, and today we'll be talking about database, specifically PostgreSQL. PostgreSQL Overview. PostgreSQL is a powerful open source object relational database management system known for its reliability, flexibility, and feature set. Developed with a focus on extensibility and compliance with SQL standards, PostgreSQL supports both traditional relation data and more complex data types like JSON arrays and key value stores. It is highly scalable, making it suitable for handling small single user applications as well as large scale enterprise level databases. PostgreSQL is widely used across industries such as finance, government, and tech startups due to its reliability, open source nature, and flexibility in handling diverse workloads. PostgreSQL Key Features. Key features of PostgreSQL: multi version concurrence control lets users write and read to database at the same time without blocking, only locking rules when multiple users try to update the same one. Scalability can handle large amounts of data and many users at once. It also supports multiple languages and character sets for international use. Cross platform works on many operating systems, including Linux, Windows, macOS, and others. Dynamic loading allows users to add custom code like new functions without restarting the server, making it flexible for new applications. ACID compliance ensures data accuracy and reliability even if there's a system crash or a power failure. Extensibility highly customizable with user defined functions and supports different programming languages like PL, PG, SQL, Python, and Java. Rich data types supports basic data types such as numbers, text, and date, and advanced ones like JSON for unstructured data arrays or geographic data. Replication and partitioning supports replication for backups or read only access and partitioning to speed up queries on large databases. PostgreSQL architecture. We will now discuss the different architectures for PostgreSQL. First, let's start with the process architecture. Client server model. PostgreSQL runs as a server, and multiple clients can connect to it at the same time to perform database operations. Backend processes. A new process is called a backend. It is created for each client to manage their requests. Master process, also known as postmaster. The master process manages these back-end processes, handling the client connections and disconnections. Memory architecture. Shared memory. This is accessible by all back-end processes. It stores the buffer cache, log tables, and server-wide data to minimize disk input-output. Process memory. Each backend process has private memory for handling its specific tasks like sorting, caching, and connection states. Wall buffers. Write ahead logging. Write ahead logging records changes before they are applied to the database. Changes are first written to the wall buffer. then flushed to the disk for recovery in case of a crash. Now, let's talk about the storage architecture. Table spaces. Disk locations where PostgreSQL stores data files. Database, a container holding schemas, tables, indices, and more. Schemas, collections of database objects like tables, views, and functions. PostgreSQL versus MySQL, a comparison. PostgreSQL and MySQL are two of the most popular open source relational database systems, each with distinct advantages. PostgreSQL is known for its advanced features and adherence to SQL standards, making it ideal for complex transactional applications. It supports a wide range of data types, including JSON, and offers advanced indexing, custom functions, and a full ACID compliance. Its multi-version concurrency control handles multiple transactions efficiently, excelling in write-heavy environments that requires high data accuracy. MySQL, in contrast, focuses on the simplicity and speed. It optimizes for read-heavy applications like web development, particularly the LAMP stack. While it supports ACID compliance, especially with the InnoDB storage engine, it's generally faster for simple operations and is often preferred for web applications needing high performance and scalability over complex functionality. In terms of extensibility, PostgreSQL offers more customization and supports more advanced queries, while MySQL is easier to manage with fewer features. Now, choosing between the two really depends on the project. PostgreSQL suits complex transaction heavy systems, meanwhile, MySQL is better for high performance web application that prioritizes speed and scalability over depth. So it's really up to you on what you feel though is better suited to handle the job that you're required to do. Now, let's look at the advantages and the disadvantages of PostgreSQL. Advantages and disadvantages of PostgreSQL. PostgreSQL is a powerful and open source relational database management system known for its extensibility and compliance with ACID principles. ACID stands for atomacy, consistency, isolation, and durability. One of its primary advantages is its customization capability, allowing users to create custom functions, operators, and data types. It supports advanced SQL functionalities, making it suitable for complex queries and handles both structured and unstructured data, including JSON. Its concurrency management via MVCC ensures efficient performance under high traffic, and its robust security features like role based access and SSL TLS support adds to its appeal. However, PostgreSQL also comes with some challenges. It has a steeper learning curve requiring expertise for proper configuration and performance optimization. For simpler workloads, it can be slower than alternatives like MySQL, and its toolset is less extensive compared to other databases. Additionally, features like replication and sharding are more complex to implement, which would limit its ease of use in distributed environments. While highly capable PostgreSQL may demand more hardware resources and is not always ideal for high write-intensive workloads without proper tuning. We will now go over PostgreSQL hardening recommendations. We will now go over the 3 hardening recommendations for securing PostgreSQL. 1. Enforce strong authentication and authorization. Use strong passwords. Ensure that all user accounts in PostgreSQL are protected with strong, complex passwords. Role-based access control. Assign users to specific roles with the principle of least privilege in mind. Limit permissions based on the user's role and revoke unnecessary superuser or admin privileges. Next, enable SSL and TLS encryption. Protect data in transit by enabling SSL TLS to encrypt communications between the PostgreSQL server and clients. This prevents unauthorized interception and tampering of the sensitive data. Lastly, regular patching and updates. PostgreSQL regularly releases updates to fix security vulnerabilities and improve performance. Ensure that the database and any extensions are regularly patched and kept up to date to minimize exposure for known vulnerabilities. By enforcing strict authentication, enabling SSL TLS encryption, and keeping the database up to date, you can significantly enhance the security posture of your PostgreSQL deployment. I hope this presentation was informative, and thank you again for watching.